So I need you to pick one of those cards. Point your finger to the card. I won't look. I'll stand in the corner. And point out a card. Okay, stop. Alright, so tell me which row is it in? The first row, the middle row, or the last row? First row. Alright. Okay, now tell me which row is in the top row, the middle row, or the bottom row?
Bottom row.
Bottom row. Okay. Great. Now everybody get out your calculators. And I need you to do the following. Start with your month. So if you're born in January, that's 1. Born in February, it's 2. If you're born in March, it's 3. Everyone have that? Okay, I now need you to add 2 plus 2 and hit enter. Yep. And then I need you to multiply by 10, so times 10, enter. And then add 6, so plus 6, enter. Divide by 2, enter. Subtract 13, so minus 13, and hit enter. And then last, divide by your month. Divide by your month. All right, what'd you get?
I didn't got the calculators.
Alexa, what'd you get? 5. Great. 1, 2, 3, 4, 5.
What?
Wow.
What?
So that's not math at all. I mean, that's not magic at all. It's just math. So what I did was I started with, I had you start with your month. And then I had you all add 2. And then multiply that by 10. Multiply the whole thing by 10. And then add 6 to that. Divide the whole thing by 2. Subtract 13. And then divide that whole thing by the month. That's what I had you do, right? And so the first part is, if he tells me what column it is and what row it's in, I know which card he has. So I have to make sure I pick it up 5th. So then it's going to be 5th from the top as well. But if I sort of simplify what I had you all do, like first I'm going to distribute the 10. So I'll end up with 10m plus 10 times 2 is 20, plus 6 over 2 minus 13 all over m. And then I simplify that further. So then I'm going to combine the 20 and the 6. So I'll get 10m plus 26 over 2 minus 13 over m. And then I divide each of these by 2. That becomes 10m over 2 is 5m. And then 26 over 2 is 13 minus 13 over m. These two cancel out, so I just get 5 over m, 5m over m, which cancel out, so I'm just left with 5.
Oh, basic algebra.
Yep.
Yeah,
So-
I noticed that.
So that one's not magic, it's just kind of fun, right? And you know, you can, it's, if you have like, you know, small cousins around, you can blow their minds with that. All right, good deal. All right, next we're going to hop back into chapter 7. I have 3 more card tricks. They get better progressively. So the next one will be better than this one. And then the next one will be, it's one I learned in a pub in England. And then the next one will be true magic. And the last one will be even better magic. All right. So here, alternative ways of finding p hat. It's also known as x over n. So you folks have seen that before. We've used it in chapter 2 when we found the proportion of people who, if I sampled 30 people and 15 of them are dog owners, then 15 out of 30 would be my proportion. Right? You all are kind of good with that. So sometimes you'll be given the number of people who said yes and your sample size, and you can find p hat from that. Pretty straightforward. Also, there'll be times where you'll be given, so this is, you need to pay attention to this part. You'll be given a percentage, like 47.2% out of 52 people, and you need to figure out what x is. So you might need to find x. How you do that? You do the same thing. You use this formula, and I'm going to plug in all the pieces. So this part goes there. This part goes there. And you have to figure out what x is. So here, I'd say, okay, 0.472 is equal to my x, stop that, x over 52. How did I do that? I multiply 52 by both sides. So I'm going to multiply this side by 52, this side by 52. So then my 52s will cancel out. And I'll end up with x on this side. And over here I'll have 0.52 times, 52 times 0.472. I should have checked my numbers first. 52 times 0.472. See how lucky I get. Oh, that's horrible. Let's make it 53 people. Okay, so I'm going to change it to 53 people. There we go. And we get 53 times 0.472, and you get 25.016. Now, can you ever sample 25.016 people? No. So you need to round this to the nearest whole number, because you can't ask a fraction of a person. So you would make this really 25, yep. Good?
Yeah.
Okay, so you'll need to know that. If you want to rearrange this, if you want to rearrange this formula, you could rearrange it and say that x is equal to NP. That's another way of doing it. Which makes sense, right? That's your expected value. My expected value of x would be NP. What do you expect x to be? Kind of all kind of flows together. Okay, great. So here is an example. Driving to work. Why am I reading? Alexa, go and read.
A random sample of 213 workers found that 128 drove to work alone. Find p hat and q hat, where p hat is a proportion of workers who drove to work alone.
Perfect. All right, so here, I found all my stuff. So here, my sample of is my n. Whenever you say the word sample of, that's your n. Please tell me I'm recording.
Yes, we are.
Good. Found that 128 drove to work alone. So x is my number of people who said yes. How many people said yes, I drive to work alone? 128. That's my number of successes. So my x is 128, my n is 213, my p hat will be x over n, 128 over 213. Your p hat had darn well better be between 0 and 1. If you end up with a p hat of 1.7, that's because you flipped them. Right? You can't have 4 out of 5 dentists cannot recommend Crest. It's got to be 3 out of 4. So this ends up being 0.601, which means that my q hat would be 1 minus 0.601, 0.399. Your p hat and q hat should have 3 decimal places. So let's flip the page. So now, looking at a random sample of 130 workers, found that 33.8% drove to work alone. So here I have sample of, that's my n. And, okay, so you're always going to be given n. Does anyone hear that? Let me get your eyes here. You're always going to be given n. You'll either be given x, the number of people who said yes, or p hat, the percent of people who said yes. How do you know which you have?
If it's between 0 and 1.
Yeah, if it's a decimal between 0 and 1, or if it has a percent on the end. If it has a percent symbol on the end, it's a percent. If it's a decimal between 0 and 1, it's a percent. Does that everyone kind of follow that? If it's a whole number that does not have a percent on the end, then it's the number of people who said yes. Does that make sense? You can't have 0.33 of a person. That's got to be a percentage. And you can't have 44% of a person. That's what, 44% of me? What, that's right. If it's a whole number, that's how many people said yes. So what am I given here? I'm getting 33.8%. What is that? Is that the number of people, or is that the percent of people? Percent of people. Good. So that is my p hat. So here, I want to find it. You can either plug it in. I'm just going to use this formula, but you could, like I said, you could plug it into that one and work your way around. X is equal to n, 130 times p hat, 0.338. And again, you're always going to need to convert your percentages to decimal, because the TI calculators don't have a percent spot on them. And you'll end up getting 43.9 people, which again, we're going to round to 44 people, because you cannot have 43.9 people. That'd be bloody and horrible. And then again, this is always going to be an actual whole number, right? And p hat will always be a percent or decimal between 0 and 1. All right, so you folks have got lab number 2. Go ahead and do lab number 2. Okay, so the first one, survey conducted by Sally Mae and Gallup survey of 1,404 people. So 1,404. So this is a survey of 1,404. That's my n. Found that 323 students. This is my number of yeses, x. So now I need to find p hat. So p hat's going to be 323 over 1,404. And what did y'all get for that?
0.23.
Sorry, was it?
0.23006.
230. Great. So give me 3 sig figs. So then my q hat will be 0.770. All right, next one. Random sample of. Again, sample of. That's my n. Found that 19.7% has a percentage symbol, so that becomes my p hat. So my x is 325, sorry. My p hat is 0.197, which means that my q hat is 0.803. And then my n is equal to 325 times 0.197. What'd y'all get for that one?
I got 64.03 and then I rounded that to
64.
yeah.
Yep, is rounded to the nearest number? 64. All good?
Isn't 325 the end?
Yeah.
Was that?
Isn't 325 the end value?
64 is X.
Oh, I'm so sorry. Yes.
I know me too.
So I totally screwed up. I'm so sorry. 325, 64. 65. I'm so sorry. Yes. Thank you. Yes. So N is my 325 and X is my 64. Perfect. Thank you for catching that and pointing it out quickly. All right. Great. So now we can use the TI 8384 to do stuff. So we're going to do, so far we have done stat edit and stat calc 1-bar stats. Yes? We've also done second bars. Those are kind of the three sort of things we've done with our calculators. This is a new one, stat test. Let's take a look at stat test. I'll pop it up here. The arrow to test. If I look at this, there's a lot of them. See, it says Z test, T test, 2-sample Z test, 2-sample T test, 1-prop Z test, 2-prop Z test. Those all, and we're going to look at those for a second. See how they all say test on the end? We do not want those. We are not doing hypothesis tests. That's chapter 8. What are we doing right now? Confidence intervals. Intervals. So see how the very last one says Z interval? We want all things that end in interval or int for short. So I'm going to arrow down. Maybe. Arrow down. And here are all of my intervals. I've got Z interval, I've got T interval, and I've got these number 2. The 2 samples are, anything that starts with a 2 is 2 samples. We do not get to 2 samples until chapter 9. So what we want is, we're working with proportions. Someone see what it says, 1-prop Z interval, and ends in interval. Here, I'll point it out to you. This one right here. That's the one we want. 1-prop Z interval. One proportion, we have one proportion, and we want an interval. So we're going to go to that one. And then we're going to input your X and your N and your confidence interval, confidence level, 0.95, 0.90, 0.99. Hit calculate, bam, right there it gives it to you. So I'll just do a quick example. I'm going to do the one we did earlier. What was the one we did earlier? We did survey of 1898 people, found that 45% of adults knew dandelions were the hardest one to control. Okay, so first I need to figure out 1898 times 0.45. 854 people. So I have 854 people. And my N was 1898. And I'm going to calculate it. Uh-oh. What did I do wrong? Stat. Test.
I think you only press it once.
Oh, wrong one. Oh, wrong one. Where? Wait. 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 There we go. Stat. Test. 1-prop Z interval. 85 people. Oh, my confidence level is 1898. Sorry, 1898. And we want a confidence level of 95%, 0.95. And that's basically what you folks got. You got 0.428 to 0.472. Correct? Yeah, so that's just a quicker, easy way of doing it. So let's try this one here. Let's try a random sample. So I will give it a shot. Random sample of 213 workers, found that 128 drove to work alone, find the 90% confidence interval. Give it a shot. Did you all do it already? Okay, do it now. Try it now on your calculator. Stat, test, one proxy interval. Make sure you do interval. I'll try it. Second, oh sorry, not second. Stat, test, one proxy interval.
You got this?
Sorry, what was your 128? 128. 213. 90% confidence interval. And you all should have gotten
Press enter.
No, you don't. Don't press enter. It's in gold line.
5, 4.
Watch it. Press enter. It's in gold line.
Oh, I got it.
Mine was not.
Look at that.
Who got that? What you get?
It's supposed to be a decimal.
So 0.546 to 0.656.
Yeah, I got that. Oh,
All right. So now go ahead and try lab problem 3A. So how you show your work is, for this one is, tell me the command you use, one proxy interval, and then what you input into it, your X, your N, and then the confidence level. And what did you get? Rafe, did you get an answer yet?
we got 0.230.
What, 230?
Yes, that's when I rendered it.
And then, and what was your second number?
So for the N, I got 1404.
So it should give you an interval. The first thing it should give you is an interval that looks something like this, the very top thing in parentheses.
Oh, okay. I read it incorrectly.
What did it give you?
So for the interval, I got 0.21158.
21158.
And then for the other one, it's 0.24853.
4853. Is that what everyone else has? Austin, what did you get?
I got the same thing.
What?
Okay. Let's go to the third person. What did everyone else got?
Yeah.
Okay. So then you need to round to 3 sig figs. Everybody round to 3 sig figs. Round it. 3 sig figs.
Oh, 0.9.
So if you round to 3 sig figs, this rounds up to 212. This also rounds up to 249. All right? Okay, good. So this is pretty easy, pretty straightforward. Chapter 7 is very much like that. Make sure you totally get and understand Chapter 7, because when we pop in Chapter 8, people start mixing them up. But yeah, especially with this, so I don't care whether you do it the long way, with the finding the critical value, plug into the formula, finding your margin of error, and then finding your confidence interval, or whether you go this way and find your confidence interval first. But then you're going to have to work backwards and find your margin of error. So that's kind of something we'll look at in just a minute. Let me go ahead and show you the answers. Here's the answers. If you did it by hand, you would get this. Same thing, only slightly differently. So here's the deal. You have your confidence interval, right? It's 0.643, comma 0.767. But I'm also going to ask you to find the point estimate and the margin of error. The point estimate you're given, so you just write that down from your problem, usually given that. But you need to figure out, if you have a confidence interval, can you find the point estimate and the margin of error? The answer is yes, you can. So I'm going to give you folks a few minutes. Take 2 minutes on your own without talking to see if by yourself you can figure out, how do I find the margin of error and the point estimate from the confidence interval? This is a mental challenge. So growth mindset, grow your brain cells, grow your mind, and try to figure it out.